So we've got p over n plus p. So then we've got 3 over n plus 3. And then we can just say that, see that here n reduces to 2 because this needs to be 5 in the denominator. And then we can say, well, so n over p is 2 over 3. So we can do that. But if they ask us to find, like since this is a reduced fraction, if they ask us to find, n and p uniquely, we'd have to cross multiply and solve. Yep. Okay. So did anyone have trouble with 14?
Yeah, I did. What does ordered pair mean?
So ordered pair, I mean, some people are thinking that's like 1 comma 2, 2 comma 3. No, it's just like any, 1 comma 1, 0 comma 0. So an ordered pair is really just like any, like x, y thing.
Oh, yeah, gotcha.
So any x, y point. So I mean, if they're telling us here that 2x plus 3y is less than 6. So the only thing we need to do, we're just going to plug in 1 comma 1 first, because they say it has to be positive integers. And so we're going to say 2 times 1 plus 3 times 1 is less than 6. So we're going to get 5 is less than 6. So that works.
And that's the only one that does work.
Right. If we plug in like 2 comma 1 or 1 comma 2, those aren't going to work because then this is going to be too big. So you can try it. So it's really just plugging in numbers again and seeing what you get. But if you don't remember what the definition of an ordered pair is, that might throw you off for a while. Okay, so let's see. Let's look at number 16. So x and y are consecutive odd integers. So the way we kind of treat that in these math problems is we basically have like, this is x, and this is x plus 2. Because if they're consecutive, like even or odd integers, we're basically going to be adding 2, like 3 and 5 or 5 and 7. So we're going to have like x and x plus 2. So essentially at this point, we just need to kind of, we have y squared minus x squared. And so we essentially just need to plug in x plus 2 squared minus x squared.
I just picked numbers for x and y instead.
That's fine too.
Then you have to multiply x plus 2 by itself.
Yeah, I mean that's fine too. The only problem is then you have to go, like all the answers are in terms of x, and you have to go through and plug them in, which is be a little careful because sometimes with they're the test making center is so smart, they know like what you're probably gonna pick like 1 and 3 or something. So they
I usually pick 2 or 3 numbers.
Okay, good. So yeah, you should sometimes, if you're gonna use this method of plugging in, and like there are a lot of answers with variables and stuff, you're like if you start plugging in the variable, what the variables are in the answers, you might get like 2 or 3 that work. So you might want to plug in more numbers if that happens, and not just stop if like B works for your number, then just stop. Okay, so I mean you can just plug in numbers for x and y and do it that way. So they say so odds. I mean we could do 1 and 3, we could do 3 and 5. We could do that, and then once we get this answer, we could see which of the answers matches up given our x, like 1 or 3, or we can do it this way. So then we can just FOIL out this x plus 2, and then the x squareds cancel, and we get something. Like we get 4x plus 4. So and everybody's like remembers how to do like foiling and stuff, right? Yeah, maybe. I mean, so it's like
multiplying it out.
Yeah, it's basically this x plus 2 squared is not just like x squared plus 2 squared. It's like x plus 2 times x plus 2.
I didn't know that's what it was called.
Yeah, no, they call that, in homeschooling stuff, you usually don't see that. Like, they don't call it foiling, but, they do in, like, other schools. So, like, first, outer, inner, last. That's what, like, the FOIL stands for. So you basically just multiply all of those, and then that's it. So you end up getting, x squared plus 4x plus 4. Yep. Okay. I guess people probably had trouble with 17, right?
Yeah, I skipped it.
Okay. So line L passes through the origin is perpendicular to the line 4x plus y equals k. All right. And so, I mean, we know that it passes through the origin. So that's going to help us a lot. So does everybody, so I mean, I'm just going to put this in slope-intercept form. So I'm going to subtract 4x from both sides. So I'm going to have y equals k minus 4x. So does everybody know how to find the slope of the line that's perpendicular to this line? Okay, so when we have parallel lines, that means same slope. And when we have perpendicular lines, that's going to be the negative reciprocal. So we're going to basically put a negative in front and we're going to flip it. So this negative 4 is going to turn into positive 1/4. So that means we're going to have y equals 1/4 x, and that's going to be our new line. So now, if the two lines intersect at the point, so they say that these two lines intersect at the point t comma t plus 1. So that means that this point is, basically, so I mean, the trick to this question is you don't need this line at all anymore. The only thing you needed this line for was finding the slope of this. Now that we have this, I mean, if we had two different variables, like, I don't know, t and like e or something, we would have to use another equation. But because we have just t and t plus 1, we can actually just plug this in here and then get our answer. So I mean, we have t plus 1 equals 1 t, and we just solve that. And, so I mean, we would just subtract t. So does this make sense? You look like a little overwhelmed.
Yeah, I'm pretty confused by it.
Okay, so I mean, basically we just have this line, we got this slope from doing the negative reciprocal of this line, and then we're just going to plug in t where we see x and t plus 1 where we see y, and then we're just going to algebraically solve.
Oh.
So, yeah, just kind of remember that we're going, this is our x, this is our y, we're going to plug it in, and then we're going to use, perpendicular, the definition of like perpendicular lines and what you do to their slope. All right, did anyone have trouble with 18?
I got 18 wrong.
Okay, so 18, they're saying the mean of x and y is k. So that means x plus y over 2 equals k.
Mm-hmm.
So now, I'm just going to multiply both sides by 2. So we get x plus y equals 2k.
Mm-hmm. And you just put that in.
Yeah, so now these,
I forgot to multiply the 2 by k. I had k plus y divided by 3 as the answer.
Oh, okay, yeah. So I mean, essentially now we have x plus, they're asking for x plus y plus z over 3 because they're asking for the average of these three numbers. So we're going to plug in the sum of x plus y, so it's going to be 2k plus z over 3. Because we're just going to substitute in the sum that we found over here. All right, so I guess people probably want to look at 19. Maybe, did people get 19 wrong?
Right.
Everybody got it right?
I skipped it.
Okay, all right, so let's, all right, so they're telling us this is an equilateral triangle and that this is 2, and every side is 2. So when we think, I mean, this might just be something that, you want to memorize or remember, but like, when we have an equilateral triangle and we draw a perpendicular like this, it's going to bisect this angle up here. So we're going to have 30 degrees, 30 degrees, and an equilateral triangle has 60-degree angles. People remember that from geometry? Yeah, okay. So essentially we have a 30, 60, 90 triangle now.
Wait, why would we put the 30s at the top?
Because in an equilateral triangle, we normally have like 60, 60, and 60. So basically, like, here this is 60 degrees, but like just because a, equilateral triangle is basically symmetric, when we like draw this line, it's going to bisect this angle. So then we get 30 and 30. So we have this triangle, and we know, I mean, there are the special right triangle formulas at the beginning of the test, and so we can use those, or, if you remember them, and we can also see that, this, like, this length 2 is bisected as well, so this is 1, and then this is root 3. So if you don't remember this is just like when you have a 30, 60, 90 triangle. The side opposite the 60 is root 3. I mean, essentially, or like multiples of it. So, you just use like, I don't know if you guys are familiar, but with like, you're going to use like these formulas here at the top.
Those are on the test, right?
Yeah. Yep. So once we get here, it's pretty easy because we're saying, well, if this whole height is root 3, then we know that the radius is root 3 divided by 2. And so then to get the area of the circle, we're just going to do pi r squared. And so that's going to be pi times square root 3 over 2 squared. So then we're going to get pi times 3 over 4. Okay. All right, so let's move on to the next section. Unless, did anybody want to go over 20? I'm having trouble with 20.
I got it wrong.
Okay,
I got it
everybody.
right.
Yeah, I mean, it's not too typical you see remainder questions. It's just like you want, I mean, they're somewhat common, but it's not like you're going to see 5 of them like you are going to see with function questions. But basically you just want to like, start, picking numbers or whatever. So I mean, for this one, 15 divided by some positive integer k, the remainder is 3, you'd start saying, well, I'm going to subtract 3 from 15. Okay, so when 15 is divided by 12, then, there's the remainder is 3, and then just work from there. And keep finding numbers smaller than it, and you will find, a finite number of numbers. All right, so let's go to number 4, or no, number 5 in section 4. So pretty much everyone gets this wrong, or, I mean, I don't know, I see a lot of people getting this wrong, but essentially we have this is at 2k, this is at 5k, and then this is, we have 2 here, and we have 6 here. So we know that the area of a triangle is 1/2 base times height, right? And we know the height is going to be 6 minus 2, so we know the height is going to be 4. So we just want to know the base. So what is the base going to be in terms of k?
Wait, and that's the 4. Is that an H?
Yeah, this
Okay.
is, sorry, this is an H. Sorry, I guess my handwriting is getting pretty bad. Okay, so the base is going to be 5k minus
Right.
2k. So that's going to be 3k. And then we're basically, using the information they give us, the area is, 18. So we're just going to plug in 18 equals 1/2 3k times 4. Because 3k is the base of the triangle and 4 is the height, and then the area is 18. And then we're just going to solve that equation, this one for k. So that's not too bad, right?
Why do people get it wrong? I mean, I got it wrong.
Okay.
I don't understand
Oh.
why is it so easy to get wrong?
I mean, a lot of people just get really like confused about, oh, they're saying a different scale. A lot of other people are, not comfortable with using like the K's in the scale and being like, oh, 5K and 2K, what is that? Yeah, it's, it shouldn't be one that a lot of people get wrong, but they do. All right, so let's go over number 6. All right, so we have 10m squared k to the negative 1 equals 100m. So usually people really like struggle with the exponent questions. Is that true as a whole kind
I really
of?
hate negative exponents. Such a simple
Negative
stuff.
exponents, okay. So I mean, really, of course, we want to remember the basics, like, because I mean, some people, my tutor even forget, like, oh, you multiply, like x squared and like x cubed, and that's gonna be x to the 5th because you add the exponents there. But then if you have like x squared cubed, then you multiply them, so that would be x to the 6th. So yes, I mean, just, obviously have those down. I mean, other than that, all the exponent questions are pretty much just algebraic manipulation. Like, I'm going to move some stuff over here. I'm going to think of some clever, like, trick to, like, somehow simplify the question or divide by something. So in here, I'm just going to start off, I mean, they say, what is m to the negative 1 in terms of k? So I'm just going to start, like, trying to get all the m's on one side. So I'm just going to divide by 10m squared. So then I get k to the negative 1 equals 10, and then this is m over m squared. And basically when, if something's in the denominator, if we move it to the numerator, we're going to change the sign of the exponent. So that's going to be 10 times m to the negative 2. And so then when we add the exponents here, we're going to get 10 times m to the negative 1. So we're basically just moving stuff around and trying to get to the answer. And so then they're asking for m to the negative 1. So we're just going to divide by 10. So we're going to get k to the negative 1 over 10, which is equal to 1 over 10k. So just a lot of like kind of dancing around, trying to rearrange things, trying to, move things to numerator, denominator, blah, blah, blah. But like, we're just going to keep trying and trying on this problem until we get like something that resembles an answer. And we're going to start with like moving the m's to one side. All right, so
I would skip this one if it was actually doing the test too.
yeah, I mean, again, if you're if you're kind of looking to not score like above 700 and you just want to get a really good score but not like a really, really, really good score, this is a great one to skip because it's going to take you a while. It's going to take tricks and this and that. I mean, it's it's a hard, in fact, actually, probably if you're even aiming for like a 720, you probably will skip this one, or 730, because it will be one of the 3 you skip on the test because it is difficult. It is going to be time consuming too. But I mean, the exponent ones are always kind of just a neat little trick, and you either see it or you don't, but if you don't see it, you can keep working and trying to see if you see it, or you can just forget it. All right, so let's look at 7. So Edna walks due east at 4 kilometers per hour, and Nancy walks north at 3 kilometers per hour. So, and then they walk for 4 hours. Yep. Okay. So that means we're just going to multiply this by 4. So then we're going to get 16 kilometers and 12 kilometers. So at this point, we're just going to draw a right triangle. This is just a Pythagorean theorem problem. And I mean, the Pythagorean theorem shows up pretty, a lot on the test. I mean, for those of you who haven't seen it. The right triangle. Have you seen this? Okay, so everybody's seen this. Okay. I mean, you guys have seen this? Yeah, okay. So so basically we have 16, we have 12, and then we're just going to do, 12 squared plus 16 squared equals, this like d squared or whatever. And we're just going to find it. All right, so let's look at...
There's a faster way to do it, though. There's a 3, 4, 5 right triangle.
Mm-hmm.
It's like a thing. If you memorize it, the two legs are 3 and 4, and then the hypotenuse is 5. Then if you see, they're just multiples of 3.
Yeah, so I mean, I don't know how extensive geometry you guys have gotten, but like, there are a couple special right triangles like 3, 4, 5, or then also 5, 12, 13. And if you remember those, like, so I mean, basically it's these special right triangles and they're multiples. So I mean, if you remember these, then you can kind of easily see that this is, these are all like multiples of this by just multiplying every side by 4. So like 3 times 4, 4 times 4, and then 5 times 4. Or you can just do it this way. But I mean, yeah, it will be a lot quicker if you do it this way. It's just, will you remember it? I mean, probably most of you will, but, being stressed on the test and everything, I'm not sure. All right. So let's look at number 8. So they're telling us, there's this quadratic function, and it's kind of, off to the side a little bit. And so they're telling us that f of b equals f of 3. So how are we going to find what f of 3 is in this graph? Like, essentially, when we see like f of 3, that means what is y at x equals 3? That's essentially what we're doing. So we're just going to count 1, 2, we're just going to count to 3, and we're going to just go up. We're going to find that. So now we're just trying to find what point on this graph also equals, whatever this number is. I mean, we could say it equals, okay, so it equals, this is like 5 here. So what other point on this parabola equals 5?
It's on the left side.
Yeah, so if we can see it by drawing a horizontal line, but essentially we're just going here, right? And then if we just want to, so now they're saying f of b, so we just want to find what x coordinate corresponds to this point. So we're going to go down, and this is -1. So like it's labeled on the diagram. We can, or not labeled, but it's like a grid, so we can see it's at -1. And so then b is -1. So I mean, it's pretty important to be very comfortable with this notation and be able to say, oh, f of 3, okay, they're saying, what is y at x equals 3? Okay, I'm going to count to 3, I'm going to go up and I'm going to find it. So I mean, that's just, pretty important even for a lot of the easier function questions to be really comfortable with that notation. All right, so let's go on to maybe number 13. Here's another good function one. So basically we want to, like find what p is somehow. So how we can do that is, again, I mean, let's just look first at like, this is pretty overwhelming, right? So then let's just look at like what is f of p going to be? So we're just going to put p everywhere we see x, right? So we're just going to put p plus 1. So we're just going to, whenever we see this notation with like, f of p, we're just going to put that p wherever we see x. So now we've got p plus 1. So they're saying 2f of p equals 20. So that means 2 times, f of p, which is p plus 1, equals 20. So this is our f of p. So then 2p plus 2 equals 20. So then 2p equals 18, because we just subtract 2 from both sides. So then p equals 9. And so then be careful, because it's not, they're not looking for what p is, and it's very tempting to just write 9 and be done with the question, but they're asking for f of 3p. So f of 3p is, again, we're just going to put 3p everywhere we see x, so we're going to do 3p plus 1. So that means, using our value of p down here that we found, we're going to do 3 times 9 plus 1. Okay. And that will be 28, and that will be the answer. So yeah, it's just really important to kind of be super comfortable with this f of something, terminology, and just put whatever's, in the parentheses wherever you see x. Okay, so let's look at, did everyone get 14 right? Yes? Okay. Nobody had trouble with 14? Maybe?
I
No?
almost got it wrong.
Okay, so it's pretty easy. We're just, basically everything hinges on the fact that this NLM is an isosceles triangle. So then, and the fact that like 125 and that angle M are, then that's just going to be equal to 180, them together. Okay, so let's, anyone have trouble with 15?
Oh, yeah, I skipped it.
Yeah? Okay. All right, so they're saying 1/5 cup of orange juice. And then the remaining 4/5 are filled with 3 parts, like orange, grapefruit, and pineapple in equal amounts. So essentially 4/5 divided by 3 is the thing, that's going to be how much like pineapple juice, how much grapefruit, and how much extra orange are added, because it's 1/3 of 4/5. So then we're going to have 4 divided by 15. So all we need to do to find how much orange juice in total is in the cup is add that original 1/5 to this new 4/15 that's being added. And of course that means we're going to have to do the common denominator, so we're going to have to multiply by 3 over 3, but then we're going to get it. All right, so let's look at number 16.
I got it wrong, and I'm still not sure how I got it wrong.
Okay. So a plus 2b is equal to 125% of 4b. So that's going to be, so also another thing you guys should be really comfortable with is writing stuff in percents, right? Like, 80%, we're going to write as 0.8. And, something over 100, right? Like, say 105%, right? We're going to write as like 1.05. So 125%, we're going to write as 1.25 times 4b. So we're going to end up saying a plus 2b equals, and this is going to be 5b. So then we're going to subtract 2b. We can get a equals 3b. And then from there, we're going to solve for the fraction a over b. So we're going to divide both signs by b. So I mean, this is something, that they don't really like, they don't really emphasize this in like a lot of algebra classes or this and that. They're like, oh, solve for x, solve for this, constant, solve for something, solve for this letter. They're not like, oh, solve for a fraction of two variables. So this is very common in like engineering classes or even like physics classes, but very, very weird in like what in like algebra or even algebra 2. So I mean, you're probably not used to seeing this and solving for a fraction, but you just treat it the exact same way, and you're going to want to like, have like, your different variables on either side or whatever, you know what I mean? You're going to want to like subtract 2b still to get like all your b's on one side, but then at the end, you're just going to divide both sides by b, so you get, this fraction a over b equals 3. That's very common in like engineering classes and stuff because you want to get a ratio that like where the units cancel out, like newtons or whatever. But it's not so common in like algebra classes. But the SAT does like to, ask you for like ratios or In fact, we just saw like the n over p thing earlier. All right, then you have trouble with 17. 17 is pretty easy. It's just if anybody got it wrong, watch your like. Watch your math basically, not like your conceptual math. Watch like your, basically what equations you set up and like, just like, did you count wrong? Because like, if you count, you realize there are 9 spaces instead of 10. So like, each of those spaces is actually 1/9. And then you need to, set that equal to like, once you count all those, so 6 times 1/9 and then equals like root x. So just, it's just kind of keeping track of all all the spaces, all your variables, and not making any careless mistakes. Okay, so let's look at number 18. Yeah, again, this is a good one to skip because it's, it's time consuming, it's kind of conceptually difficult, it's kind of hard to see. Okay, so basically, I think the easiest way, maybe you'll disagree with me, Tim. I think the easiest way is to think about like the, basically the differences and then draw a new like right triangle instead of trying to draw the points and writing out the distance formula. I think it's easier to kind of say, okay, well, in the x direction, we have 10 minus x. In the y direction, we have 18 minus 3, which is equal to 15. Is that what you did?
Yes.
Okay. Yeah, because like you could plot these and then like write the distance formula, and also you should know the distance formula. Although it's more commonly asked on the ACT, but you might see it on the SAT. But it's like this thing, x2 minus x1 squared plus y2 minus y1 squared. It's that thing. But if you start doing this problem with this, you can get the answer, but it gets kind of complicated because you've got all these squares and everything. It's kind of weird. So I just like to draw a triangle and say, okay, our y difference is 15. Our x difference is 10 minus x. And so we know that this difference is 17 because they're telling us the distance is 17. So now we're just going to do Pythagorean theorem, or just kind of figure it out intuitively. But 17 squared equals 15 squared plus 10 minus x squared. So I mean, if we solve this, we get to basically saying that like this is 289 equals 225 plus 10 minus x squared. And so then we just subtract 225. So we essentially get that 64 equals 10 minus x squared. So now it's easy to it's easy to see that 10 minus x needs to equal 8 or negative 8. So that means x is either 2 or 18. Because if it's 18, we can do 10 minus 18, which is negative 8, which is still going to produce 64 when you square it. Okay. All right, so let's move to section 8. And let's look at number 6 first. So this is another function question. And basically, they're saying, g of some number k equals 1. So when they're saying g of some variable 2 or f of some variable, that represents a number. Again, we're just looking for for what, what value of x does y equal 1? That's all this question is asking. So for what values on this graph does y equal 1?
It's from 0 to negative 1.
Yeah, so this is the region here, right? This region right here is where y equals 1. So this goes from negative 1 to 0. So, k could be anywhere in between 0 and negative 1, but the only answer is negative 0.5. So then k is negative 0.5. All right. So, yeah, again, just kind of always think of this as this is really just y and saying, y at some, number k equals 1. So we're just going to look where y equals 1. Okay. So, I mean, I guess I'll skip to 9. So, did people have trouble with 9? Oh, okay.
I skipped.
Did most people get it right?
I was down to C and D. I picked the wrong one.
Okay.
I was crunched for time.
Okay, because I mean, that's impressive that some of you got it right. Because a lot of
It's
people
annoying
seem.
because I can't really remember because I did all my work on another piece of paper.
So you don't remember how you got it
I forgot
right?
to bring the piece of paper, so I forgot how I.
Yeah, that would be interesting to see. Just because it is a hard problem, and I mean, I have kind of a weird way of solving it.
Oh,
What?
I got it wrong.
Oh, you got it wrong?
Oh. At 10. Sorry.
Jenna, did
9.
you get it right?
No, I didn't.
Okay. Okay, so no one got this one right. Okay. All right. So,
Sorry.
so basically, I think one thing you can do is you can start plugging in numbers, but I mean, this is a road that leads to just a lot of carelessness, and because what it is you can say okay, so the child needs to be between 30 inches and 50 inches tall. So you could say oh, I'm going to try 51 inches, and all the answers that work for 51 inches are wrong because we're trying to make sure that everyone that's 51 inches is excluded. So we could do it that way, and then we could say 29 inches should also be excluded, then 31 should be in, and 49 should be in. But I think the best way to think of this is kind of you guys might be familiar with this formula, but essentially it's 40 plus or minus 10. So, I mean, are any of you in chemistry or,
So chemistry.
yeah, or even physics? I mean, have you ever seen or taken a lab, seen this, it's kind of your error margin, so basically you're saying, the height of the child, is ideally 40, but it can be up to 50 and, down to 30. So it can be plus or minus 10. So now this makes the question super easy because you're just going to look for the answer with these two numbers, essentially. You're going to say, well, you're going to subtract 40. And then if that difference is more than 10, then it's the child gets thrown out of the ride. So, so basically you're saying, okay, so if it's 50 inches, then 50 minus 40, okay, so that he's just at the boundary, if he equals 40, well, then he's right at the ideal. So, I mean, you looking at it this tolerance way, or, if you really just want to kind of do it the, I don't know, quick and dirty way, you can think, okay, well, the average of these two is 40, and then how much they deviate is 10. I'm just going to look at what answer is 40 and 10. And I mean, the only answer that has 40 and 10 is D. Sorry, I guess this should be less than, because they're saying technically it's between 30 and 50, not inclusive. Okay, so I mean, essentially, so you can do it by plugging in numbers, but when you do plug in numbers, if you were going to plug in heights, for each answer, you want to choose boundary ones. So you want to choose like 51 or like 29 or like 31 or like, 49. But I think the easiest way to do it is say, okay, here's the average of them. This is how much they deviate. And then just look for the answer with that. Okay, so let's look at number 10.
I got that one right.
You got that one right. Okay, good.
That's what I was looking
So this is radius 5, height 4. And they're basically saying we're just, so then it's volume is V. So they're just saying we're doubling the height. That's all they're saying. So, I mean, essentially, they're just like, essentially they're just doubling the height. So, I mean, that's just going to double the volume. Now, if they were doubling the radius, then that would change a lot because right, exactly. We have, like, this is our equation for volume, which is in the front. But anyway, so we have this equation for volume. So when you do have, right, in the front, you have all these different equations. You have the special right triangles I was talking about. You have the volume of a cylinder. You have, the area of a triangle. Okay, so, basically, if we were doubling the radius, then we would, like, say 2 squared, essentially, right? Like, if we were saying the radius goes from 5 to, like, 10, we would have, like, 25 h pi. And then, but if it was 10, we would have like 100 h pi, right? Because that would be 10 squared and 5 squared. So like, basically with anything where it's not squared or whatever, if like the volume doubles and the height doubles, or the height doubles, the volume doubles, but like, if it's with a squared or a cube, that's when we really have to start to worry. But the easiest way to do this problem might just be, instead of worrying about all this kind of like conceptual stuff, oh, we're doubling the heights, we're doubling the volume, and you might just want to find the volume, like for the, for this one, and then find it for, it's gonna be a little more time consuming, but then, you'll be confident that you're doing the right thing. I don't know, is that what you did? Maybe?
I don't remember.
Okay.
I feel like that's what I did.
Okay, so I mean, yeah, the easy way is to just kind of compute the volume for each of these cylinders and then just see. And I mean, that's perfectly legitimate. It's just going to take you a little more time, but that's fine. Okay, so let's go on to 11. So K diamond N, R, and that only works if N is less than K is less than R. And then -2 diamond. This is pretty scary, right? No, not really.
Yeah.
Okay, so I mean, basically, we're looking at just matching like these values. So we know that this -2 is going to be our K value. So we're just going to put that in. So, and we know that this 0 matches up with our R value. And the only reason why I'm saying these values match up with each other is because like I'm just looking at the order. I'm saying K is before the diamond, so that's -2. This is N because it's like the first one after the diamond, and this one is R. So then we're going to do N is less than -2 is less than 0. So I'm just plugging in the values for each of these. And then, so I mean, really N has to be less than -2, right? So N can be -3, but it can't be anything else. Does that make sense? Okay, so number 14. Number 14, I just want to point out quickly, this is really a plug-in numbers question. I mean, you have like, these functions, and I mean, you could kind of think theoretically, okay, like 1/2 versus 1/2 squared, it gets smaller or whatever. But I mean, it's easiest to just say, okay, I'm going to say x is 1/2. And I'm going to compute, I'm going to say, okay, for, this numeral 1, I'm going to say, all right, x squared is 1/2 squared, and then x cubed is 1/2 cubed. Okay, this one is 1/8, this one is 1/4. So then basically, okay, so then x squared is greater than x cubed. And just do that for all of them. So that's really the best thing to do. So just plug in numbers with something like this. I mean, usually when they give you a range, like, x is between this and this, it's best to just plug in a number and just see how it goes. All right, so let's look at number 15. Did anyone have trouble with this one?
I skipped it.
Yeah, so I mean, these data analysis questions on the SAT are getting more and more ubiquitous. Like, it's pretty, they're pretty common. Like, you know what I mean? Like, even though they don't actually teach like real math, and they're just like, oh, here's some data or here's a graph or whatever. I don't like them for that reason. I wish they were all like theoretical. But okay, so they have data, and you have to wade through this huge paragraph of like, oh, there are mice in a maze, blah blah blah. But they're just saying here are data points. What's the function? It doesn't matter if they're mice or whatever. So you just have like all these data points. So essentially, you might notice that, I mean, one thing you might want to check is like, what does the slope seem to be of this line? I mean, the slope of the line seems to be relatively flat, right? It's not really going up, it's not really going down, it's just kind of like horizontal. Maybe? See that? So then another thing you might want to test after that, so I mean, you might say like, C and D are kind of out, like 44p or p over 44, like we're kind of looking for, and also like, p and p, p plus 44. Essentially, we get the right answer if we look at the slope, because we see that there's just like no slope. It's essentially just like horizontal line. But, so I mean, the answer is T of P is 44. But I mean, we could start checking points if you don't want to think kind of on this like, higher level of sort of, oh, the slope, the slope is just horizontal, so I'm just looking for the equation that has a horizontal slope. We might, we might check like, okay, well, when does it seem like, essentially like at 0 or near 0, does it seem like the line is going to intersect the origin? It doesn't seem like that. So I mean, like, T of P equals P, that would essentially be the line y equals x, which does go through the origin. So that doesn't make any sense. So essentially, that's another way you could look at it. All right. So basically, these data ones, usually they're pretty easy. I mean, you just want to look at what the slope is roughly, and then what the y-intercept is roughly. But here, this was just a little bit of a trick question because, like, the y-intercept is about 44, and the slope is just like horizontal. So it's just like y equals 44. Okay, so let's look at 16. Did people have trouble with 16?
Yeah, got it wrong.
Yeah, it's pretty difficult. I've only seen one person in all my tutoring days like ever get this one right. Okay, so we have so essentially we want to start by like drawing, okay, this is like where we're going to start fitting in all the tiles this way. And we want to think of the units of like, instead of thinking about the little blocks, like we're just going to think about this one big block that we're putting in. So like this is the one block that like we're putting in. So saying it's 12L by 10L. So I mean, it's pretty easy to see how many blocks are going to go, on this edge, right? Because we're going to do 12L, but then this distance is 2L, right? So we're just going to do 12L divided by 2L, and we're going to get 6. So 6 blocks, 6 of these big blocks go here. So now here's the tricky part. Well, we want to keep things, in terms of L, because this is in terms of L. So, well, what's our conversion? Well, we see 2L on this side equals 3W on this side, right? Because they're the same. I mean, it's a rectangle. It's not like some crazy like thing that's like, a trapezoid or something. So we've got 2L equals 3W. So then we've got, divide both sides by 3, we've got 2L over 3 equals W. And so then we can just, so I mean, essentially now we have L plus W is this side up here that we're looking at, putting in, right? So we've just got, essentially L plus 2/3 L, so we're going to get 5/3 L. So we're going to do the same process, just like we said 12L divided by 2L, so we're taking this length and dividing it by the side of one of these bigger blocks, and we say that's 6. We're going to do the same thing here. We're going to say 10L divided by 5/3 L. So we're just going to divide it. So I mean, it looks weird because it's a fractional, but that's fine. So then that equals 10L times 3 over 5L. And, essentially we get 6 again. Things cancel out and everything. So we realize that there are 36, 6 times 6, big blocks in here. So now we just have to, and then you might go and say, okay, 36B is the answer, right? But that's not right because they're actually asking how many blocks of L by W are there. So we've got to multiply 36 by 5 because there are 5 little blocks in this unit. And so that's how we get 180 blocks. So I mean, these are difficult questions. I mean, really the main thing, you know, if your scores are, you know, more in the 500s, you want to think about, you know, getting down the, you know, the definition of functions and being able to work with functions. And you're going to skip these more, you know, time-consuming questions for now. You know, if your scores are more in the 600s, you're looking to go to the 700s, you want to start thinking about these really difficult exponent questions or questions like this. And just think, you know, kind of, you know, you might want to do drills. You know, and I'm definitely going to, I think, so next week we're not, like, for this coming week, we don't have homework. You're willing, you know, if you totally want to, you can do the writing section with an essay, and I'll definitely take it and grade it. But I mean, we're just going to go through together a math section. So, and I don't want, you know, I kind of want everybody to be on the same page and not really doing it before and kind of struggling with it. So no homework, but, you know, if you want to do a writing section and hand me your essay, that's fine. Okay. All right, that's all.